Hey everyone, Steph here from Old Guy Melts Plastic. It's been a hot minute since I've posted any content up on my YouTube channel, and there's some reasons for that. So let's quickly talk about what happened, and not to make this a pity party because I do have some good news going forward after this, but why you haven't seen me online in so long. In 2024, we had a couple of deaths in the family. My father passed away in April. My father-in-law passed away in September. We had to put one of our pets down, a 17-year-old cat that we love, Mira. And so all of that put me in a bad emotional headspace. In addition to that, in July, I lost my tech job, which I had been working at for the past 6 years. Changes within the organization meant that my position was surplused and I was laid off. And I was unemployed from July until January of this year, so for a full 6 months. And during that time, between the deaths in the family and the loss of my job, I was feeling pretty crotchety and not really fit company for anyone. Probably mildly depressed in the sense that, I just wanted to kind of shut the world away and tell everyone to go take a hike. Not to the point where I was going to harm myself or others, but just didn't really want to do anything. It was hard to get any kind of motivation. So that's what happened in 2024. As I mentioned, the job situation picked up in 2025. In January, I started a new position with another tech company where I get to work remotely from home full time. So that's pretty fantastic. And that's going really well for me so far. But all that time, I was still kind of present in the 3D printer community, although in a much less visible capacity. I was, still on the Discord servers and interacting with people and trying to help out where I could. But I'd like to get back to some more content creation. So the good news is that I've been involved for the last almost a year now behind the scenes with a group of 3D printer enthusiasts. And the project we've been working on is called the Inertia Cube. So what I'd like to do now is share my CAD model for the Inertia Cube with you. And I want to stress this isn't my design. This is a group effort of various people. And I don't want to omit any names. So rather than try to name them all out here, I'll post a list in the video description below. And thanks to the whole team. We do have a new Discord server that you'll be able to join. It's going public, and I'll have that link in the video description as well. So without further ado, let's dive into the CAD model, and I'll talk about the build. So here we have the CAD model for the Inertia Cube printer. This was a group effort, although I've been heavily involved in kind of building out the CAD model, making sure it's complete, organizing the various components within the model. So if you like things that you see in the CAD model, it's probably due to my efforts on structuring and organizing the CAD model. The individual component designs are, from a number of different individuals on the Inertia Bro design team. So that is the name of our new Discord server, is Inertia Bros Designs. So you'll find a link to the Discord server in the video description below, and look forward to interacting with you guys on that server. Let's have a look at the frame. So for the frame, we're leveraging 30-30 extrusions for the external frame. The 30-30 extrusions give us lots of space around the blind joints to route wires down the extrusion slots. And if you go down the vertical extrusions, you get to run wires from the very top of the printer all the way down to the very bottom into the electronics bay. So you can get wires all the way down by running them through this extrusion slot. And this gap here is all empty space. So there's room for at least 5, 6, I think I've run as many as 8 wires in that space if they're small enough gauges. Running wires in the extrusion slots is very nice from a visibility perspective. You can easily hide all the wires behind some extrusion slot covers. However, might not be optimal from a serviceability perspective in case you're constantly kind of fiddling with your printer or rewiring things, or in case you have to service it for something later on. Admittedly, that's a bit of a trade-off. So although I will be routing my wires through the extrusion slots, you do whatever makes sense to you. We will have alternatives and alternative wiring paths that you can leverage instead if this isn't something you want to go through. The ZAxis, we have a few different things going on here. So the Z-axis is an example of a component where we have, let me just try and get the right view here. We have these fixed parts on the outside, so the lead screw motors, we're leveraging 4 lead screw motors in each of the corners to provide a quad gantry level bed leveling algorithm. And so the lead screw motors are attached via Z-joints. The CAD is organized such that if there are static parts that don't move relative to the frame, then they are in a static parts folder and kind of all of the assemblies from there. In each of the different sections, you'll see non-printed, so that would be fasteners, hardware you'd have to buy, such as the motors themselves, fans, electronics, et cetera, and then printed. So printed is all of the plastic parts that you'll print on your printer in order to finish the build. So you can quickly go through the CAD and look at all the printed folders in each of the sections, and they could be nested down the tree depending on how this is organized. And then when we look at the printed parts folder, let me just give another example here with the monolithic gantry. There's a few things about parts that you might want to know. If there is, this is a bad example, but if there is an X at the end of the part name with a number at the end, that means print that part that many times. So X times 4, X4 would be print 4 copies of that part. If there is a D in parenthesis at the start of the part name, that tells you that the part is designed with dual color printing in mind. If you have access to a dual color printer and you want to export it and print it in dual colors in your slicer, then you can absolutely do that. If you don't or don't want to, you can obviously export it and print it as a single color part. That is fine, but there is, in this example, a logo that is hard to see in this view. Let me see, there we go, I can pull it up that way. So this blue logo is our Voron design logo. The arrow faces up and to the right. And so that logo is in blue on the black background part. Our design choice for color scheme is black is the primary color and blue is the accent color. Obviously, you do what you like. My personal printer is my traditional purple and blue, sky blue color theme, so I'm going to vary from this, but this is the model and color scheme that we've gone for as a team. Where you see a printed part that has an A in parenthesis, then that part is intended to be printed in the accent color, so just a single color part, but in the accent color rather than the primary color. And otherwise, if the part name does not have anything in parenthesis, then print it in the primary color. Another thing about the axes, and I'll start with the Z-axis, for example, we have this concept of static parts which don't move relative to the frame, and motion parts or moving parts. Moving parts is anything that has physical motion as the printer motors are engaging. So in this case, the bed can slide up and down, and I implemented this as a separate kind of selectable group, so that component, so that I could very easily check for collisions with other assemblies in the printer. So it allows me to easily figure out range of motion of the parts just from the CAD model. And I do that for all 3 axes, the X, Y, and Z axes. So we can very easily look for things like tool head collisions into the XY joints or into the motor mounts in the corners. So, and you'll be able to just, wherever you see moving parts, so you see it here and also here, for example, if I select the Y gantry, I can just move, that is just, this is the Y gantry, so this is, I lie. This is the Y gantry. So this is the entire gantry that can slide back and forth. And then let's just go back to 0 here. Similarly, if we have within here, I have the X-axis, and that allows me to slide the tool head left to right through that axis. So if you're designing a mod for the printer, I heartily recommend that you design your mod in concert with the full CAD so that you can very easily check your mod to be sure it fits within the build space and doesn't collide with any of the other assemblies. All right, while we're looking at the gantry, because let's move right along to that. The gantry is based on Cloaked Wayne's monolithic monolith gantry mod that he originally released for the Voron printers. We have Cloaked Wayne's blessing to leverage his gantry design. We've taken his design and we've kind of modified it for our own requirements and needs. A few things about the gantry design, and let's look at the, let me hide the panels here just for now, give us a bit more clarity and visibility into this. You know what, I'm just going to turn everything else off for the moment. Okay, so with the gantry, we have a few things. The front motor assemblies, we have double shear motor plates. So the motor shafts, in this case, motors are bottom mounted and the shafts are 35 millimeters. There is a bearing, a flange bearing underneath this double shear plate that helps to keep the motor shaft from being pulled or warped or bent when you're tensioning the belts, if you're running the belts at high tension. We have this tensioner, front tensioner adjuster for the bottom belt, and on the right side, we have the same idea for the top belt. So this M5 bolt is how you adjust the tension for the bottom and top belts. And you simply tighten them. The entire motor and the tensioner assembly has 5 millimeters of travel in the y-axis. So that gives you some ability to tension the belts. If the tensioner assemblies are all the way back, then they're loose. And as you tighten this bolt, it pulls the tensioner assembly forward, adding more tension to the belts. By default, we want the belt tension while the tensioners are loose to be pretty snug and tight. You'll see in one of the assembly videos, we have a belt puller tool to help cinch the belts on one side of the carriage part and then pull them both tight evenly through the other side of the carriage part. So we want a good amount of tension on the belts. I can't tell you in pounds of force or foot pounds or newtons. I don't know how to talk that, but whatever it is, I'm fairly certain it would be considered high tension in some of the other builds, but we're getting really good results with that. So that's the front tensioner assemblies, and front and center, no other tensioner assemblies within the belt pathing. The monolith belt pathing provides what we think is the shortest Core XY belt pathing, and we leverage less pulleys and bearings, less tooth idlers. So we have 4 tooth idlers in the build. We have 4 pulleys in the build, 1 on each motor. And then a number of bearing stacks. I can't recall exactly how many, maybe 10, 12. And so it provides the shortest belt path to iterate. My previous belt on this early designs of this printer used a more traditional Core XY belt routing path, and my previous belts were almost 300 millimeters too long. So we shaved probably a good 300 millimeters off the previous belt requirement by just leveraging the monolith belt path rather than the traditional core XY belt path. And so shorter belts typically results in less resonance, especially at tighter belt tensions. Tighter belt tensions are easier to achieve with the shorter belts. So yeah, we're getting good results with that. In addition to the quad gantry with the monolith rails, the other elephant in the room with this build are these linear rods. So I don't have a good design reason why we chose linear rods or an engineering reason. Some other successful commercial builds, not going to name names, leverage linear rods in one or more axes, and so we thought, let's see what happens. So these are M12 stainless steel rods with an LM12UU bearing on each one. The bearing is captured by the XY joints, and so that is how we install our Y-axis routing or Y-axis motion. Also, these rods, if you loosen or remove 8 bolts, so the 2 at the back here, the matching 2 on the front assembly, and then the 4 bolts on the XY joint that capture the bearing, you can slide the entire rod and bearing assembly out to the left for relubing, replacement, any kind of service required. So it's very easy to disassemble parts of the printer for servicing without having to undo everything to get at the part you want to service. All of the motor mounts are independent in the corners, obviously other than the belt routing, so you want to be careful of that. Yeah, so linear rods, 12 millimeter linear rods rather than extrusions and linear rails. Why? Good question. Something to try just to be different. Has it helped? I think so. Do I have measurable results to confirm that it helped? No. They are subjective results, but I'm really happy with the design and build so far. This has been by far the easiest printer for me to build, and I've built a few on this channel, and we're getting really great performance results. With this gantry, between the monolith rails, the monolith belt routing, the Y rails, or Y rods rather, I am also leveraging an MGM12 linear rail for the X-axis, and the Z-axis is also using MGM12 linear rails. My X-axis linear rail is a Berserker rail from West 3D, so thank you to Dan and the team at West 3D for that. So the Berserker rails have always given me really good performance in my other builds, and that's what I have for my X rail. With this configuration and with the stability that the 3030 extrusions give to the frame, I'm easily able to achieve, without much tuning effort at all, using input shaper kind of results to gauge success. I get belt similarity tests in the high 90s, 98, 99%, 99.8%, I think was the best I achieved for belt similarity tests using input shaper, or using the ADXL to measure belt similarities. And I'm getting easily 18,000 to 20,000 recommended accelerations on both X and Y. For smooth MZV values, I'm using Calico for my we're using the Calico build of Clipper for this build, and getting really good results with the smooth MZV at 18 to 20,000 accels. And I am by far not a perfectionist. I am just a good enoughist. And it took me like 10 minutes of tuning to get those results out of the printer. So granted, I've been through this a few times by now. I've tuned a few printers, but I'd far from call myself a tuning expert or perfectionist. And even so, I'm able to get those pretty fantastic results. And I really like that the X and Y accelerations that we're getting as recommended accelerations are relatively balanced as well, which means you don't have the desire to go faster in one axis and not be able to because you can't compensate for it in the other axis. So that's been really great. All right, let's talk about the tool head. So our tool head is comprised of two plastic parts. The first plastic part is what we call the main body, which is the front plastic part, the traditional tool head. The second plastic part would be the carriage plate, carriage adapter. So this carriage is designed for the monolith belt routing, which means that the belt teeth face to the rear of the printer rather than to the front of the printer, as is typical with a Core XY belt routing. And so the main body, the front of the tool head, is a single plastic part. So there's no assembling of multiple parts. The hot end bolts right into this plastic part, as does the 25 by 10 hot end cooling fan and the twin 4010 blower fans. The hot end main body also has, see if I can get it from underneath here, mounting slots for a couple of NeoPixel PCBs. If you have like the single NeoPixel PCBs from like a stealth burner build or something like that, those can slot right in here. The carriage part has two bolts to attach a eddy current scanner to use as bed mesh scanner, and also for your Z probe. So whether you use a USB toolhead PCB such as a Nighthawk 36, or whether you use a CAN bus PCB such as an EBB 36 from Big Tree Tech, and the Nighthawk 36 obviously from LDO. So if you're going USB, I'd recommend like a Nighthawk 36 plus maybe a beacon over USB, or if you prefer a cartographer over USB. If you're going to be using CAN bus, so then I'd recommend like a Big Tree Tech EBB 36 for the toolhead PCB, and a cartographer probe for the eddy current scanner, and over CAN bus. Sorry about that, having some congestion issues here, getting over a cold. So yes, the tool head is designed, heavily influenced on Chirpy's excellent Yavoth one-part tool head. We really like the concept. We tweaked it a little bit, made it our own, made most of the walls thicker, and adjusted kind of the overall aesthetic to fit what we were looking for. But it's heavily inspired by Chirpy's designs. Chirpy, you may know better from his Rapid Burner and Dragon Burner tool head designs. The Yavoth was a less publicized design of his that he allowed us to kind of remix for our needs. And we're quite happy with the performance of this. It's a very rigid tool head. Given that it's only a single plastic part, it's actually very chunky, as is the single part of the carriage. The tool head itself, you'll notice, has no front accessible bolts. So the tool head main body is bolted to the carriage plate via 4 bolts on the rear. Let's see if I can bring those into focus here. 2 up top in the middle, and then 2 down here and down below. So it has 4 attachment points. Because the carriage plate is a single part, because the tool head is a single part, that makes the rigidity of this like stronger than any other tool head I've built in the past, and simpler as well, because less parts to fiddle with. Removing the tool head main body is very easy. You just remove these 4 bolts. And if you then also remove these 2 bolts that attach the toolhead PCB mount plate to the carriage body, or the carriage plate, then you can lift the entire toolhead, extruder, and toolhead PCB assembly straight up off of this and pull it away for servicing or disassembly or whatever you need to do. So that's a toolhead in a nutshell. So thank you to Chirpy for his excellent design in Yavoth, which is a great inspiration for us in kind of making it fit our needs and requirements. Onto the extruder. The extruder is, again, a hodgepodge of two different designs. So the back end of the extruder is leveraging the excellent work by Jared C. in the Voron community for his Galileo 2 standalone extruder. So it uses that motor and the planetary gear set from the Galileo 2 standalone extruder, married with, I'm gonna hide this, see if I can hide the plate here, married with the front gears of a LDO Orbiter 2 gear set. So it's, again, a mixture of the two. We've, again, changed the aesthetics to fit what we're looking for. We've given ourselves an ECAS to capture the PTFE tube for the filament. And this has proven very good for us. The 3 bolts that attach the extruder to the tool head provide a nice stable platform when combined with the 2 bolts that connect the tool head PCB plate to the carriage plate. You get a very stable, rock solid tool head that doesn't feel flimsy at all. Feels very much like a and you know, although it feels very solid and doesn't shake, it has not a lot of weight to it. It's relatively light. I forget the exact weight, but it was on par with like a Dragon burner, maybe a Rapid burner when we did comparison weights. So despite being very rigid, we're not adding any additional weight to the gantry, so or to the X gantry. So that's good. So there we go, a new tool head and extruder design to complement the monolith gantry, and that's been working very well for us. To complement the frame and the panels, we'll talk about the panels in a minute, but we have the fridge door. We're calling it the fridge door. It is in fact a cookie clack door, which was made popular in the Voron community by Whopping Pochards, so I might be mispronouncing that, and I apologize. Whopping, thank you for all of your many designs and mods over the years with the Voron community and others. This is one of my favorite door assemblies now. I have it on a couple of printers. I am installing it on more. And so we decided we liked what we saw, so we're leveraging it. We had to modify a couple of things because parts of the hinges and the latch plate need to fix into the 30-30 extrusion of the frame rather than the door extrusion. So we had to make some tweaks to fit our particular build, but by and large, this is Whopping's design without very many modifications. So thanks to him for all that he does for the community. Electronics, we don't have this fully fleshed out yet. You do need, because we have 4 Z motors and 4 gantry motors, you do need at least a main MCU that is capable of 8 stepper drivers, so that limits your options. We tend to like the Big Tree Tech products, but there are other 8 stepper driver boards that you could leverage as well. We will have configuration files available on release for the Octopus Pro 1.1, which has the H723 chipset. And we'll also have an Manta M8P v2.0 configuration available, as well as a Big Tree Tech Kraken. If you like to use other products from FISEC or other manufacturers, as long as it has 8 stepper motor drivers, you should be set and ready to go. This initial build is leveraging only a 24 volt power supply. You obviously could break it out and use 48 volts if that's your wish, or even 60 volts, provided that you have the appropriate, safety precautions and also the right hardware to handle, the right electronics hardware to handle those higher voltages, so stepper drivers and the appropriate MCUs. But initially, the base build will only leverage 24 volt, single 24 volt PSU. What else can I say about the electronics? We do have lighting that is provided in the build by either daylight or disco on a stick PCBs. Is that also Wapping's design? I apologize. The daylight or disco PCB designer, thank you for that. I apologize if I've got the wrong individual, but you know who you are. It's an excellent design. It means much less soldering for Steph. Steph hates soldering, so I personally thank you very much for that. And we do leverage two of them, two PCBs at the top of the build space. And if you want to bling out the electronics bay, you can also install two daylight or disco PCBs in the electronics bay to kind of have some underglow effect through the skirts. Panels. So let's talk about panels for a second. Panels are all nothing special. So we have the top, the side panels, and the front door panel, which are all intended to be transparent, clear. I like to get mine made out of polycarbonate, but acrylic works fine. The rear deck and bottom panels are intended to be opaque, and I usually get mine made out of ACM, and I like to use my good friend Sean from Happy Manufacturing. He is the guy that I go to for all of my custom panel work, and he's able to not only cut panels to size but also install, I believe it's a vinyl sticker or a decal onto one or both sides of the panel so that you can have like a design represented similar to what you'd see with a Cricut. So yes, links to Happy Manufacturing will be in the video description below. Do reach out to Happy. He's a great guy, does great work, and I really appreciate all the help he's been with my panel acquisitions for all of my printer builds. In addition to panels, obviously, for fixing the panels to the extrusion frames, I personally have always really appreciated Ann Lin from the Annex Engineering team. Ann Lin has what I think is a really excellent design for panel clips because they are all printed plastic parts. They don't require any double-sided tape or VHB tape. They don't require any fastener hardware to affix the panels to the extrusion slots. You simply rotate these blue keys 90 degrees, two in the corner, one on each of the middle parts. And once you rotate the keys so that they're running parallel to the extrusion slot, you can remove the panel clip directly. And once all the panel clips are removed around a panel, you can then easily slide the panel off the appropriate face, set them to the side in case you need to remove the panels for servicing, or you just want to be able to print in other materials where more ventilation is good. Ann Lin's panel clip design originally was for 2020 extrusions. It has been remixed by others. I believe it was Chaos Maker for 1515 extrusions. And it's a testament to Ann Lin's excellent design that I was very easily able to remix these for 3030 extrusions simply by scaling the X and Y dimensions in this example for the top clips, scaling those dimensions out by 1.33, I think it was, and effectively did nothing else. These particular keys are designed with a 5.5 millimeter gap between the top of the panel and the inside of the extrusion slot. That 5.5 millimeter gap means that a 3 millimeter panel with 3 millimeter foam will cover will get compressed by 0.5 millimeter. The foam will get compressed by 0.5 millimeter when you lock these panel clips in place. So you get a nice seal of the panel against the extrusions. That's it for the walkthrough of this build. So let's just put it all back to the way it was. We are very much looking forward to the whole Inertia Brothers Designs team is very much looking forward to seeing you on the Discord server. Again, the link to the new Discord server will be available in the video description below. And yeah, hopefully the design is intriguing and you want to build this printer. I don't know how much of the information will be publicly available right away. We do have to work with both LDO and West 3D and DLL PDF to, the desire is to have kits available, but self-sourcing might be an option as well at some point. I can't say when that'll happen, but hopefully not too far in the future from now. So thank you very much for watching. Good to be back on the tube, and hope you enjoy working with the new Inertia Cube build going forward. Looking forward to seeing you guys on our Discord server. And I also have a build series for this printer that I've already put in the can in YouTube. So they're already ready to go, and I'll make them publicly available as this goes public. But thank you very much again for tuning in. Hope to see you again online, and thanks for watching. Bye for now.